So hello, this is our third task, which will be DC motor, control a DC motor with Arduino and L298 motor driver. So this is our circuit. I already drawn this in your Proteus. So I am showing how you can take other components. So this one, if you write here pick component and then write L298, then you will be having this two things. So the second one, which will be this one, will be using the schematic model L298. So if you click OK, so this will be available here and you can choose this as well. And for this motor, we will be using the motor. So if you write here DC motor, then many things are available, and this one we will be using this one, motor active simple DC motor. So you need to double click this one and then it will be available in your component list. And push button, for push button you can write push, so PUSH, then this one button active SPST push button. So this will be available. And other things, okay, so these things is new quite here. So typically we have used this power from this power setting, that is the terminal mode. This power, this one is already available and we have used in other experiments as well. But this is you know that first of all this power is basically plus 5 volt, and here we will be supplying plus 12 volt, and to supply this we will be using from here generator mode and then DC. So if you click on DC and let's say put it here, now if you double click this and here the voltage, so if you write let's say 12, then it will be giving 12 voltage. And if you connect like this one, you can connect this, this portion is connected, let's say connect it from here. Okay, so I'm just showing how to connect. You can really connect here, so like this one. So through this you can connect this, and obviously you don't connect VCC to this out 3 pin. I'm just showing how to connect. You will connect like this, it is already connected. So I think all components here I demonstrated. Now let's move on to the code. So this is the code that we'll be needing DC motor. So first of all, you know that we'll be using our enable as a PWM pin. That's why we have defined ENA as a enable, and we have used pin number 9. And for iron on and iron 2, that was our 2 input corresponding to 2 output for motor A, we have used pin number 6 and pin number 7. So this portion, and similarly we have connected our push button to button number 4. So these are just pin definition. And second, we have defined how we will be using, whether it will be output or input. And the enable and the in on and into or will be the output pin. That means we will be sending signal from those pins. So that's why this will be the output pin, and we will be using that button as input. Why input? Because through this button we will be send some signal to our Arduino. That's why this button will be used as input. And in the void loop, first of all we will be reading that A0 pin using analog read. So integer port value analog read A0, and then this portion is similar to our task 2. We will be mapping that value, because that analog read A0 will be from 0 to 1023, and PWM pin we generally send from 0 to 255. So 255, that means the 100% duty cycle, and 0 means 0% duty cycle. So the PWM pins generally take from 0 to 255 value. So that's why you are changing that analog read to 0 to 255 range. That's why we are mapping that port value that was initially 0 to 1023, and now it will be having 0 to 255. So next you are just analog writing enable A as PWM output. So you can understand that enable pin was just PWM pin, that was pin number 9, and it has PWM capabilities. And to use PWM feature we generally analog write. And why it is not digital write? Because digital write basically either high or low, and we will be sending values, continuous values from 0 to 255, right? That's why we will be using analog write, and then our pin, that is ENA, and then the PWM output, this one we will be writing. So through these three lines we will be sending PWM signal, and if this PWM output is, let's say, 255, then it will be 100% duty cycle. That means the motor will rotate at its highest speed, and if it is 0, then it will be 0% duty cycle. So technically it will be stopped. So this portion for speed control. And now if you want to perform like this, if button is high, then you will be rotating it clockwise. So button high, how do you will read? So digital write button, and if it is high, then you will be rotating it clockwise. And I already mentioned that to rotate is clockwise, let's say you need to send in one high and also into low. So this combination will give, let's say, clockwise direction. And if you want to rotate it anti-clockwise, then you need to give a different signal, just the opposite one. So for that anti-clockwise direction, you can give digital write IN on low, and similarly IN to high. So initially we have given high low for clockwise direction, and now if you convert this to low and high, it will rotate anti-clockwise. So that's why you have written like digital write button high. So whenever that button will be high, it will rotate this direction, and if that button will be low, it will be rotating in the reverse direction. So that is our code. And now if I click on this verify, so it will be compiling. So now it is done compiling. So you need to copy this directory, Control C, and then you need to show it here. So Control A, Control V. So now okay, so code is uploaded. Now if I click on this run the simulation, so now if you notice, it is rotating anti-clockwise. Why anti-clockwise? Because if you notice here, now the button state is generally 0, because now the button is not pressed. That's why this pin number 4 is getting a 0 from this ground. That's why it is rotating anti-clockwise. Now if you press is like this, and it will be rotating clockwise. Now if you release it, it will be rotating at anti-clockwise again. So to have a clockwise direction, you need to press it. That means you need to have a connection to this power supply. So whenever it will be connected, this pin number 4 will get a high signal. So if you click on this red portion, then it will be pressed automatically. So now it will be rotating clockwise. And if you press on this red portion again, that means if you release it, then it will be rotating anti-clockwise. So this is the task 3 that I just demonstrated. Now let's move on to our lab report. So I just demonstrated the code, and this one also done. So now the homework, so let me describe it. So you need to connect another motor B to the motor driver, and also another push button. So for this you can connect another motor with this out 3 and out 4, just like this motor connection, and then also you need another push button just like this. So you can use another push button like this configuration, and you can connect to any pin. This could be pin 3, 5, 8, 10 or anything. So you need to connect this, and then you need to operate like this. So when both push button will be off, that means both push button will be released, then you need to have both motor stops. And whenever you have this connection, that means whenever you press on push button 2 and not pressed on push button on, then you need to have motor A is in clockwise direction and motor B is anti-clockwise direction. And if you sense this like push button 1 is pressed and push button T is not, then you need to have motor A is in anti-clockwise and B is in clockwise. And at last, whenever both push button is pressed, you need to have both motor clockwise direction run. So this is the thing that you need to perform in your home, and then you need to submit the screenshot of this schematic. So obviously you will draw the schematic, you will have another motor and also another push button, and then you need to submit the screenshot. And obviously you can submit the screenshot whenever it is running, since at the time of running I can't check whether it is clockwise direction or anti-clockwise direction. So one screenshot of this whole schematic will be fine in your report. And also you need to show your student ID here. And to do this, I think you already know this 2D graphics text mode. If you have this, and then if you write your student ID, and then if you click on OK, so this student ID will be available. So you will write your student ID and then you will take the screenshot, and one screenshot for this whole schematic should be fine. So then you also submit the source code that you have written in Arduino for this operation that I demonstrated and showed in as homework. And also there should be a discussion session in your lab report where you will discuss what have you done, is there any problem that you have faced, and what is the solution, and so on. So that's all. Thank you everyone.